still have that question of, is speed an important part? Dr. Joe Bowler, she's a professor who studies how people learn math. That's what you see in those YouTube videos. What did she say? She said not speed, but she said something else is important in math. Do you remember what she said? She said not speed, but something else.
Slow.
Do you remember, Samaya? Say it one more time. Slow and something. Slow and... Addison, you remember?
Slow helps you better because slow thinking helps you understand it more and it helps you understand it more and it helps you do it.
Yeah. So speed is not important. Go ahead and write a big old capital no with an exclamation point.
A big no.
A big no. On your page. We want slow, and she said deep thinking. Slow, deep thinking. Now again, does that mean that you can't have your addition facts memorized? No, cool. It'll totally help you to know that. Does that mean that you should not memorize your multiplication facts? No, if that is a strategy that works for your brain, you're good at memorizing, go for it. But that also means that I will not be doing any timed tests. There will be none of that. Why? Speed's not important. I don't care if you know your twos in a minute. That's not helpful to me, because guess what? A calculator can still do it faster than that. But you know what a calculator can't do?
What?
Deep thinking. Calculator can't do deep thinking. Calculator can figure out those problems really quick. Can figure out 3 plus 3 really fast. But you know what it can't do? It can't figure out that express lane problem that we did last week. It can't figure out, should I go in the express lane or should I not? Can't figure that out. You can. So we need that slow, deep. Right. No. We're going to do a task today. It's called the robot stepper. This will be a really good chance for you to practice understanding and remembering speed is not important and that mistakes are okay. Some of you will probably do this faster than others, and that's okay. So we're going to pretend that we've got these robots, and our robots take different amount of steps. Depending on how they've been coded, they might take a different amount of steps. Some of our robots, they move 8 steps at a time. Some of our robots move 4 steps at a time. Some of our robots only move 3 steps at a time, and some of our robots only move 2 steps at a time. Nope, you don't need to write any of this down. Alright, so I need Paxton come see me, Colby come see me, Arik come see me, and Cole come see me. Come on up.
Wait, you do 4 3.
You're not doing anything with that.
Can I put this?
Yes. Come here. Alright, Colby, since you're first, Colby is my 8-step robot. Say hi, 8-step robot.
Hi, 8-step robot.
Paxton is next. Paxton is my 4-step robot. Say hi, 4-step robot.
Hi, 4-step robot.
Alright, is my 3-step robot. Say hi, 3-step robot.
Hi, 3-step robot.
And then Cole is my 2-step robot. Say hi, 2-step robot.
Hi, 2-step robot.
Alright, robots. I know this is your first day being a robot. Congratulations. But when you take a step, look at my feet. Look at my feet. I'm not taking steps like this. I take steps like this. Heel to toe.
Oh my God.
Alright, so in a minute, you are going to take, robots, 1 step. For you, how many steps is that actually? How many steps is that for you, actually? How many steps is that for you, actually?
3.
How many steps is that for you, actually? Does that make sense? Ready, set, robots, go!
Who will win? Who won the race?
Who will win? Alright, you only did 3 steps, friend. Is this 8? Okay, so we did our steps. As predicted, as I'm sure you predicted, Cole's robot, 2-step robot, that one didn't go very far. Why not? It's not because Cole doesn't want to step. Maverick, why is Cole's robot not going very far?
Because he did it too fast.
He did it too fast. Nope. Think about what he just did. Julian, why is Cole's robot not going very far?
Maybe because he was slow.
Not because he was slow. Nope, they all went the same speed. Why did Cole's robot not go very far, Lydia?
Because he only took 2 steps.
He only took 2 steps. He's a 2-step robot. Colby is really far.
Yeah.
Colby didn't go faster than Cole. How did Colby's robot get so far forward? He's much farther ahead than Cole. How did Colby's robot get so much farther ahead? Marley?
Because he took 8 steps.
He took 8 steps. So the 8-step robot is going to go farther than the 2-step robot. Arik and Paxton are pretty close together. That's because they took almost the same amount of steps. Arik took 3 steps. Paxton took 4 steps. Arik actually took a lot more steps, and then he had to back up because Arik doing 3 steps. It's fine. So are we fine with this? We understand 2-step robot does not go as far as an 8-step robot.
Yes.
Go sit down, robots. Thank you. Give me a round of applause for my robots. Thank you, robots. All right, so today we are going to be predicting the number that are, or not predicting, figuring out the number that our robots land. So on that paper, actually I'm gonna back up. On that paper, it reads, Part 1, explore the walks of all 4 of your robots. If they start at 0 on a number line, find at least the first 5 numbers they land on. Put your finger where it says 2-step robot, the very first line that says 2-step robot. So if I am the 2-step robot, and I am starting at 0, pretend I'm on a number line. What's the next number that I'm going to land on? It's not 1. It's not a 1-step robot. Think about it. Raise your hand if you figured it out. Emma?
2.
2. Watch my counting. Ready? 0, 1, 2. I landed on that second number. Next to that 0, there's a line there. Write number 2.
Oh, I put 0, 1, 2.
No, that's not what I asked you to do. It's not a 1-step robot. It's a 2-step robot.
I put 1.
It's not a 1-step robot. It's a 2-step robot. It didn't stop on 1. It stopped on 2. What's the next number that 2-step robot is going to land on? It stopped at 2. Where is it going to go next?
4.
This is the part where you raise your hand. All right. 4. 4. 2. 4. 4 is the next landing number. Write a 4. What's the next landing number for that 2-step robot? What's the next landing number? If you don't know, start at 4 and count on 2. Marley? 6. All right, pause. So far, does that make sense? Could you keep going? Yes. Put your finger where it says 8-step robot. Put your finger where it says 8-step robot. Now, if my 8-step robot starts at 0, you already have a 0. What's its first landing number? Don't yell at me, raise your hand. It's not 2. Brogan? for an 8-step robot going 8 numbers is going to be 8. Make sure you're on the 8-step robot. And then you're going to write 8. We got 0, we got 8. Make sure you're in the 8-step robot section.
0 to 8.
So I'm going to do a question. Why don't we listen to my directions? Because right now you're not showing me that you even know what to do yet. What's going to be the next landing number? Think about it. If you're not sure, count on start at 8 and count on 8 more. Use those fingers. Connor. Obi? 16. So a lot of you go 8, 9, 10, 11, 12, 13, 14, 15, 16, and just count on 8 more steps. Does that make sense?
Yeah.
So far, so good.
Yeah.
We're okay with that.
Yeah.
Do we think that we can do all of the 2-step spots, all of the 3-step spots, all of the 4-step spots, and finish the 8-step spot?
Yeah.
Okay. Don't worry about part 2 yet. Part 2 is at the bottom. You see it?
Yeah,
Don't mess with part 2 yet. Only worry about part 1. I am going to put you in partners. So now let me finish my directions and then you can go, okay? The first person in the partnership is going to get a number line. I have number lines. Now, they only go up to, I'm not sure, 20, 30? 25. But they might help you. Do you have to use it? No. But they might help you. The first person is going to grab a number line for you and your partner to share. The second person in the partnership is going to pick the spot. Does that make sense?
Yes.
Great. Pause and look at your paper. Did you write your name on it?
Yeah.
No. Yeah, some of you still did put your name on it. Come on, you can go. So we're starting at new numbers this time for part 2. Next to 2-step robot, write 17. Next to 3-step robot, you're going to start at 7. Write 7 next to 3-step robot. Next to 4-step robot, you're going to start at 10 this time. And then 8-step robot, you're going to start at 2. This is going to change your landing numbers. They are still taking 2 steps or 3 steps or 4 steps or 8 steps. But now your landing numbers are going to be different because they started in a new spot. Does that make sense?
Yes.
All right. Finish part 1 with your partner. Then move on to part 2. Go ahead and keep working.